Hello, welcome to Darasa Online. My name is Mr. Kileo Abubakar Davidson. I am a geography teacher, and today we are going to study topographical map interpretation, subtopic understanding features on a map, and we are going to focus on what we call the cross-section or the cross profile. See how to draw it. Then after understanding on different procedure or steps on how to draw the cross-section or the cross profile, then you will see how to calculate the vertical exaggeration as well as how to find the gradient between the 2 points on a map. Lastly, we will check on how to find or to identify the intervisibility between 2 points on a map given. Okay, so let's see what is cross-section or what is cross profile. Cross-section we refer to the diagram drawn between 2 points on a map to show physical features that fall between the 2 points. Okay, as I've said that we are going to look on cross-section. So what is cross-section? Cross-section we refer to the diagram drawn to represent the relief features on a map between 2 points. Listen to me very carefully. It's the diagram drawn to represent the relief features. We stick there between 2 points on a map. So what are the relief features? The relief features, it can be either the natural or the artificial features that cut across the 2 points on a given map. Okay, so can you see, for instance, we have an example here. As you can see, this is a diagram drawn to represent the relief features between 2 points on a map as clear or given. I repeat it, we refer to the diagram drawn to represent either natural or artificial features between the 2 points, point A and B. We have given 2 points right here, and we have drawn the diagram according to the features that cut across the 2 points on a map. The diagram drawn, we call it the cross-section or the cross profile. Right there, we have two types of cross-section. We have the simple cross profile as well as the annotated cross profile. So what is the simple cross profile and what is the annotated cross profile? The simple cross profile we refer to the cross profile or the diagram that is drawn with no title or shading like this. That's why we call it, it is a simple cross profile, or it is a simple diagram drawn to represent the physical features without labeling or indicating them. So as you can see, for instance, this is annotated because it has title and we have labeled, we have indicating the features, see, between 2 points on the map. So if we remove this, the features, see, if we remove the features, then it means our cross profile right now, it changed from the annotated into the simple one. See, no title, no shading. See, it just shows what? It shows the topography. It just shows the topography, as you can see. It just shows the topography. That is a simple cross profile. It is a diagram because it indicates the configuration of the map area between the 2 points. As you can see, we have the steep slope right here. We have the swallow, or we have the steep right there. We have the escarpment or the upland area between the 2 points. So it is a simple because it got no title, no shading, you see, no labeling of the features between the 2 points. So let's see how to draw the cross profile between the 2 points. So right now we are going to see the procedure on how to draw the cross profile or the relief features between the 2 points on a map. Right now we are going to see the procedure for drawing the cross profile or the cross section. So let's assume we have given 2 points. Right now we are supposed, or we are asked to draw the cross profile or the cross section between the 2 points on a map. So remember, the 2 points may be given by either a place name, maybe this is point A and this is point B, or the 2 points may be given by using the grid reference point. So as a Form 6 student, I know you know how to use either the place name to identify the position of those area, or the grid reference point to identify the 2 points. So let's see the first procedure. Identify the 2 points on a given map. It means the first procedure is to identify the 2 points asked, because the question normally asks that draw the cross section between point A and point B. You see, how do the question asked how are they asked the question so that you can be able to, or you can be asked to. The question asked this way. Question: draw the cross profile between point A and point B. See? Draw the cross profile between point A and point B. It means we have point A and we have point B. So the point, I mean, the key needs right here is how are you going to identify point A and point B on your map? Because first you have to identify the 2 points on a map. That's why the first procedure is identify the 2 points on a map. So you can identify them. You can identify them by using either the grid reference point or a place name. Let's see the diagram right here. You see, for instance, we have the diagram, this diagram right here. It means you can see we have point A and point B. So let's say maybe the question asked me, draw the cross section between point A and point B. It means the first procedure is to identify the 2 points. Where are the 2 points? It means you have to find where is point A and where is point B. This is the first procedure. See, I write here. I mean, I have written here. Identify the 2 points on your map. You see, refer the figure point A and point B. It means by using our figure right here, we have given the point A and point B. It means they use a place name. This point here, its name is A, and this point here, its name is B. So that is the first procedure. We have already identified the 2 points. It means we go to the second step. The second step said, join the 2 points by using the straight line. Right now, I have already joined my 2 points by using the straight line. As you can see right here, this is point A, this is point B. I have joined the 2 points by using what? By using the straight line. The third stage, it means observe carefully the physical features and the contour line cut across the line between the 2 points. See? Observe carefully the physical features and what? And the contour lines that cut across the straight line joining the 2 points. It means we have to observe carefully. See? This is my straight line. It means which contour cut across my line, my straight line. It means we have this one, you see? Then you go, we have this one. This is the contour, 100 contour. Then we have this one, 80. We have this one, 60. Then we go, we find this one, another contour which cut across my line, 60. You see, here we have 80. Here we have 100. Then you go there, we have 100. We have also 80. We have 60. Then we have 40, etc. See? I have observed carefully. Then I found there are different contours, lines that cut across my straight line. So if there is any features, for instance, railway, there is a road that cut or a river that cut across your line, it means you have to observe. And later you have to make sure you mark them into the edge of piece of paper. See, that is the first stage. It's written right here. Observe carefully the physical feature and the contour line cut across the line between the 2 points. So after observing careful, it means the last procedure, or the first procedure, you have to transfer the features into the edge of the piece of paper. Into the edge of piece of paper. You have to make sure you transfer them. You see the features that cut across the straight line between the 2 points, you have to transfer them into the edge of piece of paper. You see? So let's see an example on how are you going to transfer them. We have different contours. So how are you going to mark them or to transfer them into the edge of piece of paper? Let's say this is our piece of paper. This one, it is a piece of paper. Then I have to make sure each contour that cut across the 2 lines, for instance, this is point A and this is point B, I have to make sure I transfer them into the edge of piece of paper. It is a piece of paper. Right here, this is the edge of the piece of paper. As you can see, my contour written right here, 20. Then I will mark right here, 20. See? This one. Then the second contour, it marks 20. Then I will mark into the edge of piece of paper. How much? 40. Then we go 60. We go 80, 100, 120. So as the contours marked on the, I mean, between the contour cut across my lines, then I will mark them into the edge of piece of paper. As you can see right here, this is the edge of piece of paper. I have marked my two, I mean, the straight line between the 2 points. Then I have marked what? The contours cut across the line. Thereafter, after making sure you have transferred them, the contour from what? From I mean, on your map between the 2 points into the edge of piece of paper. Thereafter, you have to follow another step, which is finding the vertical scale according to the contour line, and draw the vertical line at the end of the lines. It means you have to observe carefully your contours. You have to observe carefully your contours. You see, you have 20, 40, 60, 80, 100. It means you have to find the vertical scale according to the contour interval that you have. You see? So I can say maybe, how am I going to find the vertical scale? It means on finding the vertical scale, you have to be very careful. You have to look careful on the contours interval that cut across that line. For instance, in my diagram here, I have 20, 40, 60, 80. So how am I going to find my vertical scale? It means I may say either, let's say 1 centimeter, I will use 1 centimeter to represent 20 meter. You see? This will be my what? My vertical scale. Or someone may use maybe 1 centimeter representing 40 meter. This is my vertical scale. See? So you may change it and put it into ratio. You can say 1 centimeter right here represent 20 meters. So you can change 1 centimeter represent 20, which will be equal to this one. What? Centimeter. Then I will divide 1 centimeter by 1 centimeter. 1 ratio, this one. This will be my vertical scale. See? Or for instance, if you may use this one, 1 centimeter is equal to 40 meter, it means you may change it into centimeter. This one, 1 centimeter is equal to 40 meter, which is equal to this one centimeter. Divide by 1 centimeter by 1 centimeter, get 1 ratio, how much? Ratio 4,000. This will be my vertical scale. So it depends. Someone may choose 1 centimeter represent 20 meter. That's according to him or her. Another one may choose 1 centimeter is equal to this one. That's according to him or her. See, so I mean, different people, they may use different vertical scale of, I mean, on the same answer, I mean, question. Then from there, after finding the vertical scale, it means, let's go back. After finding the vertical scale, it means right now you will draw your line. It means let assume this is point A and this is point B. Let's assume this is point A and this is point B. So what are you going to do right now? What are you going to do is after finding the vertical scale, it means we have to draw the vertical line at the end of the 2 points. See? Remember, my point is A and my point is B. So at the end, you have to draw the vertical line. This as the vertical line at the end of the 2 points. Thereafter, I'll work on my vertical scale that I got from, I mean, with respect or in relation to the contour intervals that I have. Then from there, I'll make sure maybe, so let's say I'll take the edge of the piece of paper. Then this is the edge of the piece of paper. And I have marked all of my contour lines that have cut across this line. You see, 80, 100, then 80, then 60, then 40, then 20. See? Then from there, I have chosen my scale. I have already chosen my vertical scale. See, let's say I have used 1 centimeter. It means the point from this point to this point is 1 centimeter. I repeat, this point to this point, it is 1 centimeter. So remember, I said either one may say 1 centimeter is equal to 20 meter, or another one may use 1 centimeter is equal to 40 meter. So it depends. See, and it may differ according to the, I mean, the way people or students choose his or her what a contour interval. I mean, the vertical scale depending on the contour interval. So you can see one may use 1 centimeter represent 20 meter, or the other one may use 1 centimeter represent 40 meter. So let's say we use 1 centimeter represent 20 meter. You see, let's say we use our vertical scale 1 centimeter represent 20 meters. Then from there, it means I'll use 20, After 1 centimeter, 20, it means 40. After 1 centimeter, 20, it means 60. After 1 centimeter, 20, see, 100. So you mark it as the same as to both sides. 20, this will be 60, 80, 100, 120. See? The other one may decide maybe I draw 1 centimeter is equal to 40 meter. It will be the same. See? It will be the same. So after drawing the two line at the end, after drawing the two line at the end of what? Of the 2 points between your line, it means you have to make sure you join the 2 points according to the contour interval that cut across the line, you see? So you have to make sure, okay, this is 20, it means this is 20. This is 40, then you go there, this is 40. This is 60, then you mark where there is 60, see? This is 80, you go there, this is 80, see? This is 80, there. 100, this is 100. Then from there, 80, you go use this one. 100, it is there. Then 80 is there, 60, 40, 20 there. So you connect the dotted lines that you have been drawing. See? And lastly, you'll find something like this. It means we have the diagram there we drawn. So the diagram obtained between the 2 points, I repeat, the diagram drawn between the 2 points is what we call the cross-section. So as you can see the procedure there, it means after transferring the features into the edge of the piece of paper, then I have to find the vertical scale according to the contour lines. See, I have given the contour lines. The contour lines, I have 20, 40, 60, 80, 100, 120. It means I have choose that let this be my what? My vertical scale. So it means this is 1 centimeter, 20 meter, 1 centimeter, 20 meter, 1 centimeter, 20 meter. So you write it the same in both sides at the end of these 2 points. Then from there, you can shade, you see, because we are asked draw the vertical line already, shade the diagram, write the title indicating features, where lastly you can indicate both vertical scale and the map scale provided. It means from here, you can shade your diagram. See? So if there is any feature that cut across the line, you may label them or indicating them. So for instance, maybe if there are walls, you see, maybe a river cut across this point, you may indicating there is a river and you label it. So according to our question, we don't have the river, the railway, or any road cut across the line. We just have the what? The contour lines cut across the line. So you leave as it is. Then after shading, it means you have to write the title. Our title is what? Because the question asked that draw the cross-section between point A and point B. That is our question. Then the title will be the cross-section, between, the cross-section between point A and B. This will be your title. Thereafter, they told us, they asked us, the last, you can indicate both vertical scale and the map scale. It means you may write our vertical scale. This vertical scale is equal to 1 centimeter, represent 20 meter, and we may write also the map scale given. The map scale is always given. I mean, from your map, it's always, so it can be anywhere. Either this one or the given map scale, you can write it down. So this is how to draw the simple cross profile or the simple, how to draw either the annotated or the simple cross profile. See, this is a common procedure on how to draw the cross section. Thereafter, you may be asked to find what you call the vertical exaggeration. So listen to me very careful. What is vertical exaggeration? Or sometimes you may be asked to find what we call the gradient. So you have to be very careful on finding the gradient because it's related to our cross-section. Remember, gradient will refer to the steepness or the gentleness of the slope in your diagram, okay? How steepness or gentleness is the slope is between the 2 points on a map. Thereafter, you may be asked to find what we call the intervisibility between the 2 points. The intervisibility between the 2 points, it means we are talking about, do these 2 points A and B can be seen from one another? That is what we call the intervisibility. See, so according to our diagram, there is no intervisibility between the 2 points, because once you want to join the 2 points, you see this point, let's assume this is point A and this is point B, they cannot see from each other. Let's assume someone is standing right here. You see, they cannot see someone who is standing right here. So if one person is standing in this point and one person is standing in this point, it means the two persons, they cannot see each other. So the 2 points are not intervisible. But let's assume maybe this diagram went to this direction. You see, if someone was standing in this point and someone was standing in this point, it means that the 2 points can be seen from each other, and we say that the 2 points are intervisible. But according to our question right here, the 2 points are intervisible. Why? Because the 2 points cannot be seen from one another or from each other. Then from there, let's see how to find what we call the vertical exaggeration or the gradient. Let's see how to find the vertical exaggeration between the 2 points on a map. So what is vertical exaggeration by definition? Vertical exaggeration refers to the number of times by which the vertical scale is larger than the horizontal scale. Number of times by which the vertical scale is larger than the horizontal scale. It means right now we want to know or to identify or to determine how many times vertical scale is larger than the horizontal scale, you see? Or in other way we can say we want to determine or to identify how many times horizontal scale is smaller than the vertical scale. So remember, horizontal scale we refer to the map scale, while the vertical scale, it is a scale that you have obtained after assuming, you see, assuming the contour interval according to the scale you wanted. So for instance, I said according to our diagram right here, we have assumed that this is our vertical scale, that I assumed that this point from this point is 1 centimeter. So my 1 centimeter will represent 20 what? 20 meter. It means this is my vertical scale. Then our horizontal scale is what we call the map scale provided, normally indicated or shown on your map sheet. See? So let's assume this is our what? This is our map scale. So if we want to find the vertical scale, it means you have to, if you want to find the vertical exaggeration, you have to take the vertical scale that you have created, that you have assumed, divided by the map scale or the horizontal scale given. So let's go there to see how to find the vertical exaggeration. According to our example, I said, according to our example, it means vertical scale is equal to, vertical exaggeration is equal to the vertical scale, which is equal to 1:2000. See? Divided by the horizontal scale. I said the horizontal scale will refer to the map scale provided, and the map scale provided is 1:50,000. See, so here will be right 1:50,000. That is our map scale or the horizontal scale. So right now we have to take this one divided by this one. You see, so if you take this one divided by this one, you will get is equal to how much? It means you will take 50 divided by 2000. See, so it will be equal to 25 times. It means vertical exaggeration is equal to 25 times. See, then we say, or we conclude, I think this one divided by this one is similar or is equal to take this one, the denominator of horizontal scale, which is this one, divided by the denominator of what? Of the vertical scale, which is equal to this one. So if you take 50,000 divided by 2,000, you will get 25. So because we said vertical exaggeration refers to the number of times by which the vertical scale is larger than the horizontal scale, then right now we write vertical exaggeration is equal to 25 times. It means the vertical scale is larger than the horizontal scale 25 times. Or in opposite of it, we can say the horizontal scale is smaller than the vertical scale 25 times. That's why vertical exaggeration is equal to 25 times. Remember, in a standard point of view, normally the vertical scale cannot exceed 10. So you have to make sure when you are choosing your vertical scale between the according to a contour interval, make sure your vertical scale does not exceed 10. It means right here, what I mean is that 1 is less or equal to vertical exaggeration, and vertical exaggeration is less than what? Than 10. This should be your standard, so that to avoid the cross section not to be too large or not to be too low. Too small. See, so sometimes you can draw if you assume. If you go wrong, or you assume maybe your vertical scale too large, it means that then you will draw the vertical, the cross section too small. And if you avoid, you assume your vertical scale too small, it means that then you are going to draw your cross section too large. So in that point, you have to make sure that you have to find the vertical exaggeration before drawing what? Your cross section. As advanced student, I insist that before drawing your cross section, make sure you find the vertical exaggeration. By assuming that let me use this vertical scale, then you relate with the given map scale to see the cross section, the vertical exaggeration that you have obtained. And make sure your vertical exaggeration is between 1 and 10. You see, because right now we have calculated our vertical scale according to our diagram. According to our cross section, and we have found it as 25 times, which is too much big. You see, and this is how. So by summarizing. Let's assume we are not talking about the cross section. We are talking about the vertical exaggeration. How to find the vertical exaggeration? We find the vertical exaggeration by doing what? By taking the vertical scale divided by the horizontal scale, or we take the denominator of horizontal scale divided by the denominator of vertical scale. This is my vertical scale. It means this is the denominator of what? Of the vertical scale. This is my horizontal scale. It means this one, 50,000. This 50,000 is my what? Is my denominator of the vertical scale. So sometimes we may take a denominator of horizontal scale divided by the denominator of vertical scale. Okay. Let's see how to calculate another question. Simple question like this one. The map scale, given the map scale of 1:50,000. And the vertical scale of 1 centimeter to 100 meter. Calculate the vertical exaggeration. So this question, as you can see right here, we have the map scale. Remember, I told you the vertical exaggeration refer to the number of times by which the vertical scale is the number of times by which the vertical scale is larger than the horizontal scale. It means we want to know how many times the vertical scale is larger than the horizontal scale, or the map scale. So we have given here the map scale is this one, and the vertical scale, it is 1 centimeter to 100 meter. It means we know solution. It means we have the givens. See, we have the map scale. The map scale, which is 1:50,000. 1:50,000. Then we have the vertical scale. Vertical scale 1 centimeter represent 100 meter. This is as to say as 1 centimeter is equal to 10,000 what? Is equal to 10,000 centimeter. Is equal to 10,000 what? Centimeter. So this is equal to 1:10,000. This one. See? And we have the map scale. Remember, the map scale is equal to the horizontal scale. So from there, it means the vertical exaggeration is equal to the vertical scale over the horizontal scale, or the map scale. The horizontal scale, or the map scale provided. So from our question right here, because we have the map scale, which is equivalent or is equal to the horizontal scale, and we have the vertical scale from there, we can find the vertical exaggeration. It means the vertical exaggeration is equal to the vertical scale, which is equal to 1:10,000 divided by the horizontal scale, which is equivalent to the map scale provided, which is equal to 1:50,000. So it is equal to 50,000 divided by 10,000, which is equal to 5 times. It means the vertical exaggeration right now, vertical exaggeration is equal to 5 times. Therefore, vertical exaggeration is equal to 5 times. What does it mean? It means that the vertical scale is larger than the horizontal 5 times, or the horizontal scale is smaller than the vertical scale by how many times? By 5 times. Okay, let's see another question so that we can. Okay, so we have seen how to calculate the vertical exaggeration, and right now let's see how to find the gradient, or to calculate the gradient between the 2 points on a given cross section or cross profile. Okay, remember what is gradient? Gradient refers to the steepness or gentleness of the slope between the 2 points on a map. See, we have asked to draw the cross section between the 2 points on a map. This is point A and this is point B. So what is a gradient? We refer to the steepness or the gentleness of the slope between the 2 points on a map. So how are we going to find the gradient between the 2 points? It means gradient we refer to the how are we going to find the gradient? Means gradient is equal to the vertical increase divided by the horizontal equivalent. Listen to me very careful. Gradient we refer to the vertical increase divided by the horizontal equivalent. So what is vertical increase and what is horizontal equivalent? You see, vertical increase refers to the difference between the highest contour and the lowest contour between the 2 points. You see, it means we have the contour which cut across the line between the 2 points. You see, remember, in drawing cross section, you are asked to draw the cross section between the 2 points on a map. See, after identifying the 2 points on a map, it means you have to join the 2 points by using a straight line. Thereafter, you have to observe and mark all the contour lines that cut across that line. You see, so we have different contours that cut across that line. Thereafter, the contour lines that cut across that line, you have to observe, to look careful which one it is the smallest contour and which one it is the highest contour. See, therefore, in order to find the vertical increase, because in order to find the gradient, we must find what we call the vertical increase. And we have told you right here, vertical increase refers to the difference between the highest contour and the lowest contour that cut across that line. You see? So let us refer to our diagram right here so that I can show what is vertical increase. You see? The lowest contour right here, it is 20, and the highest contour, as you can see, is 120. So it means what is vertical increase? Vertical increase refers to the difference between the highest contour that cut across the 2 points between the straight line, which is this is point B and this one is point A. The lowest contour is 20 and the highest contour is 120. It means the vertical increase, we take the highest contour, which is 120, minus the lowest contour, which is 20. Are we together? Then from there, we'll find what is vertical equivalent. It means the vertical equivalent refers to the exact distance between the 2 points on a map. Exact distance between the 2 points on a map. It means right now we have to take the ruler. You see, you can take a ruler and then you can measure the length of the straight line between the 2 points on the map. See? So listen to me very careful. Right now, the vertical increase, we will get it in a meter, which is on the actual ground, while the distance between the 2 points on the map can be in centimeter, because it is a distance between the 2 points on a map. Right there, are we together? That horizontal equivalent will refer to the exact distance between the 2 points on a map. It means the distance that we will get after measuring the 2 points on a map will be in centimeter, and it is a distance on a map. While the the vertical increase will be the distance on the actual ground. So let's go how to find the gradient in a simple way. The gradient means, how are we going to find the gradient? How are we going to find the gradient between the 2 points? It's very simple. It's very simple. Gradient is equal to the vertical increase. You take the highest contour minus the lowest contour, which is 120 meter minus 20 meter divided by the horizontal equivalent, exact distance between the 2 points on the map. So if you take your ruler and let's say you measure the distance between the 2 points, it means this is point A and this is point B. You can take your ruler and you can measure the distance between the 2 points. So let's say the distance between the 2 points is 10 centimeters, okay? The distance between the 2 points, let's assume the distance between these 2 points is 10 centimeters. Then we go there. It means the horizontal equivalent is equal to 10 centimeters. So how are we going to calculate the gradient in this point? We'll have to take 120 meter minus 20 meter, which is equal to 100 meter, divided by 10 centimeter. Then how are we going to calculate the gradient right here? Make sure, you have to note that the difference right here are in actual ground. And right now they are in meter. And the distance right here is on a map. It is on a map. So you cannot make any calculation if the two measurements, they differ in terms of where they are. You have to make sure they are on the same side. Either they are all on the actual ground or they are all on what? On a map. So we have to use the map scale either to take this distance which is on a map into the actual ground, or you have to take the map scale to change this distance right here, which is on the actual ground, into the map unit or map measurement. So we have our map scale. This is our map scale right here, 1:50,000. This is our map scale, which says that this one, it says 1 centimeter on a map represent half kilometer ground on the ground. You see, 1 centimeter on the map it represents half kilometer on the ground. So you have to change this 1 centimeter, which is on the map, into what? Into the actual measurement units. It means I will say 1 centimeter is equal to half kilometer. Then how about this 1 centimeter which is on a map, which 10 centimeter, which is on a map, will give me how many kilometers. See, thereafter we'll change into meter by using what? The normal mathematical calculation. It means from here we will get x is equal to how much? Is equal to 5 kilometers. So 5 kilometers is equivalent to 5,000 5,000 meter. So have you seen right now that okay, this 10 centimeter which is on a map right now is equivalent or is equal to 5,000 meter. Then from there you can be able to calculate your gradient. It means gradient from here will be equal to this one, 100 meter, which is on the actual ground, divided by, see, this one. But this one is on the map. Right now we have changed this one measurement which is on the map into what? Into the actual ground. And we have got this one. I mean 5,000 what? 5,000 meter. Then you write 5,000 meter. Then from there, this is on the actual ground and this one is on the actual ground. Are we together? Then from there you can be able to what? To do the normal mathematical calculation. It means this meter and this meter will be away. Then you will cancel this one and this one. Then our gradient will be equal to 1/50. You see, that will be our what? Our gradient. Then the gradient which means at every 150, every 1 feet, it means there is a slope of 50 meter downward. It either increase or decrease by how much? By 50 meter. At every 1 feet, it means there is decreasing or increasing of 50 meter or 50 meters ahead. This is our gradient. Then from there, you can be able to find what we call the slope. Remember slope is equal to the tan inverse of gradient. And remember we have gradient. It means to find the slope is equal to tan inverse of gradient, which is equal to 1:50. Okay, we have another question. It says the actual distance between the 2 points on a map with a scale 1:50,000 is 4 centimeters. So listen to me very careful. The actual the actual distance between 2 points on a map, with the actual distance between 2 points on a map, with this scale is 4 centimeters. So we have the distance on the map, which is 4 centimeters, and we have the map scale right there, which is 1:50,000. Then they said point A is at 400 meters and point B is at 800 meters. It means the altitude of point A is at this altitude or height, and point B is at this altitude or height. How can you determine the steepness or gentleness of the given 2 points? How are we going to determine or to calculate the gentleness or the steepness between the 2 points? It means right now the question needs us to explain or to calculate what called the gradient. See, because gradient or slope is what called the steepness or the gentleness between the 2 points. So we go back. We write down the data or the given solution. It means the givens are the givens. It means we have the map scale. Map scale is equal to 1:50,000. I'm sure we are together from there. Then we have the actual distance on a map. It means we have the what we call the horizontal equivalent. Horizontal equivalent. Because if you try to say what is horizontal equivalent, we refer to the actual distance between the 2 points on a map, the actual distance between the 2 points on a map, where right now we have it is 4 centimeters. Then from there, we were asked or we were told that point A is at this altitude and point B is at this altitude. You see, point A is at 400 meter altitude and point B is at 800 meters altitude. It means by using this 400 and 800 meter, we can be able to find what we call the vertical increase. It means vertical increase will take 800 meter minus 400 meters. You see? So we have what we call the vertical increase. Vertical increase. Vertical increase, we take the highest contour minus the lowest contour. It means we take the 800 meter minus 400 what? Meter. So from there, we can be able to find what we call the gradient. Because how are we going to determine or to calculate the steepness or the gentleness between the 2 points? It means right now they need us to calculate what? The gradient. Gradient is required. See? Then from there, we know what is the gradient. The formula for calculating the gradient, that the gradient is equal to the vertical increase divided by the horizontal equivalent. Horizontal what? Equivalent. Divided by the horizontal equivalent. So from there, vertical increase is how much? It means we take highest contour minus the lowest contour, which is equal to 400 meter. This one, 400 meter. Horizontal equivalent, we have here. The horizontal equivalent is 4 centimeters. The actual distance between the 2 points on the map, which is 4 centimeters. Then from there, remember I told you that this one, the vertical increase, this one is on the actual ground, while the 4 centimeter given is on a map. So we cannot make calculation when they are not on the same side. See, so we have to make sure the two given measurements, they are on the same side. It means they are either on the map or they are either on the actual ground. So we have to change one of them to be, to go into the other side. So we may change, for instance, this one, 4 centimeter, which is on the map, to go into what? Into the actual ground by using what? By using the map scale provided. So by referring the map scale provided, it means this is our map scale. What does it say? It says 1 centimeter on the map is equal to a half kilometer on the actual ground. So we ask ourselves, how about this one? You see, how about this one? So we put here, how about 4 centimeter is equal to how many kilometer? You see, then from there you get XC, see, is equal to 2 kilometer. With this 2 kilometer, because right here we are in meter, it means this 2 kilometers is equal to 2,000 what? 2,000 meter. Then we will substitute there. Instead of writing 4 centimeter, which is on the map right now, we can use, or we have converted 4 centimeter, which is on the map, into into the actual ground units, which right now we have what? We have 2,000 what? 2,000 meter. Then from there, I can write 400 meter divided by this one, which is our horizontal equivalent. But now we have changed it from 4 centimeter, which is on the map, into the actual ground units or measurement, which right now it is 200 meters, 2,000 meters. Right now it is 2,000 meters. So we'll get is equal to 1:1/5. Because if you take this one, it will cancel this one, then 4/1, 4/5, okay? Then we find our gradient is 1/5. Then gradient is equal to 1/5. It means at every 1 feet there is a decrease or increase of the slope by 5. Thank you very much. Thank you very much. By summarizing, right now we have seen how to calculate the vertical exaggeration as a gradient, how to draw, how to use different procedure to draw the cross profile of the cross section. So let's see, let us see the importance, okay, of cross section to our real life. So it means we connect the importance of drawing the cross profile with the real situation in our daily life, okay? Cross-section help to determine the height of the landscape on a map. As we have seen before, that through cross-section we can be able to find or to determine the steepness of the land between the 2 points on a map. So if you can be able to determine the steepness or the slope of land between the 2 points, it means you can be able to determine the height, see, of that land. Then from there, it helps to in planning the construction structure based on the geological pattern. See, for instance, if we want to construct the bridge, see, across between the 2 points on a certain land, it means you have to make sure you know the geological pattern of that land between the 2 points. See, thereafter, features like anticline, syncline faults can be seen on the cross section. That's a good that's one among the importance of drawing the cross section. But it shows features between the 2 points, features like river, railway, roads, saddle, coal, you see, etc., etc. This is we call the natural features. It means through cross section, once you draw the cross section between the 2 points, you can be able to determine either natural or artificial features like this one, as I've mentioned. See, then it helps to determine the nature of the slope or gradient between the 2 points on the map. See, as we have seen earlier, how to draw. To draw the cross section, and at the same time, how are you going to find or to determine or to calculate the slope or the gradient between the 2 points? Through cross section, you can be able to determine the nature of the slope or gradient between the between the 2 points on your map. Thank you very much. You are welcome once again on the next period, and I'm going to leave you with this question right here as a quiz that gives the clear procedures on how to draw the cross section between the 2 points on the map. So right now you're supposed to know the procedure on how to draw the cross section, let's say between point A and point B on a given map. So you can use it as exercise. You can take any map, you know, and you can try to find the 2 points and try to draw the cross section between the 2 points that you may choose according to your map. You are most welcome and have a nice day until the next session. Thank you very much.